Okay. Thanks for coming. It's a great pleasure to be able to introduce someone who probably needs no introduction, but I'll say a few words anyway. So Peter Achinstein, one of the most profound and diverse philosophers of science in the last half of the 20th century, and he keeps going in the 21st. Being productive. His latest book on evidence, Newton and Maxwell, came out a couple of years ago, maybe a year ago. So he started by doing, his first book was back in '68 on concepts, and then he moved on to do some work on explanation, developing his own account of explanation. And then he turned into various issues in the history of science and conceptual change and realism, and he published a number of papers and books, including the one that was awarded the Lakatos Prize, I think in 1992 or so, the book Particles and Waves. And he carried on working on issues of confirmation and evidence with a marvelous book called The Book of Evidence in the early 20th century, 21st century. And you can summarize, he touched more or less any issue in general philosophy of science, but you could say that he's done really profound work on confirmation, explanation, and realism. And today, it's a great pleasure for me to introduce him, to give this talk with the title, What is a Theory of Everything, and Why Should We Want One? So, Peter.
Well, it's a pleasure to be here, and it's a pleasure to be introduced by a very prominent philosopher, your own Stathis. I hope he stays here and stays very prominent. Let's see, if I go here, I can look at my notes. About 6 months ago, I was walking on the Johns Hopkins campus, and I met the Dean of Arts and Sciences at Hopkins, and she said, "Peter, what are you doing lately?" And I said, "Well, I'm interested in this, in writing a paper on, what is a theory of everything and why should we want one?" And she responded, "Everybody wants a theory of evidence. Who cares? A theory of everything," I said. Who cares? And that took me down a peg. But 2 months later, she was fired. And I think I take full responsibility for this. So okay. It's a very grand idea, a theory of everything. It's a theory that can unify everything in a simple way and explain everything there is. Okay, that's basically what a theory of everything is supposed to do. And it's supposed to explain everything, or be capable of explaining everything, on the basis of a set of fundamental laws, that is, laws which have no further explanation, and laws which govern a set of basic entities, those which can't be decomposed into anything further. At least those who talk about developing a theory of everything seem to have these ideas in mind. And furthermore, they think that there is one, whether or not they have found it. Okay? And some of them think there must be one, whether or not they will ever find it. And for them, a theory of everything exists. It's an abstract idea. It exists whether or not it's ever discovered. It's like a proof that maybe never discovered but exists. Or like a law of nature, which might never be discovered but exists nevertheless. So let me give you some examples. Now, the most prominent example is string theory from physics. And string theory tells you that everything is composed of strings that are vibrating in, take your pick, 11 dimensions of space-time. Okay, most of these dimensions are curled up so we never observe them, but the various vibrations of this string are, produce the various particles that, you know, like electrons or photons or whatever it is that used to be called fundamental particles. The people who believe, or at least want to pursue this theory of everything, is the string theory, think that they can solve, in addition to explaining everything that they want to have explained, they think they can solve certain problems. So I turn to a more or less popular exposition of this by Lee Smolin, who is an opponent of string theory. And he tells you that right out, but he wants to tell you what he opposes, so he's going to tell you what string theory is supposed to do. And he lists 5 problems that string theory is supposed to solve as a theory of everything. It's supposed to combine general relativity and quantum theory into a single theory that can claim to be the complete theory of nature. This is called the problem of quantum gravity. That's the first thing. And then he says the theory is supposed to resolve the problems in the foundation of quantum mechanics, either by making sense of the theory of quantum mechanics as it stands, or by inventing a new theory that does make sense. Right? And the third thing is to determine whether or not the various particles and forces that physicists postulate can be unified in a theory that explains them all as a manifestation of a single fundamental entity. That's the string. Right? So that's the third problem that string theorists want to solve. And the fourth one is to explain how the values of the free constants, lots of constants in nature out there, in the standard model of particle physics are chosen in nature. In other words, here are these arbitrary constants. String theory wants to give you a theory from which you can determine why the constants are what they are. And then finally explain dark matter and dark energy. These are the 5 problems that Smolin lists as the basic ones that string theory wants to solve. And it tries to solve them by imagining, as I said, that the world is composed of these strings which are vibrating in multidimensional space-time. And the strings can be open strings or it can be closed loops, and they vibrate in different patterns, giving rise to things like electrons and quarks. Okay, now what counts as everything on this theory? Well, they leave that open. I mean, some physicists think that, well, if you solve these basic problems, that's about as good as everything, okay? But the guys like Steven Weinberg and Brian Greene, who are, again, more or less popularizers of these ideas, are reductionists. And they think that everything means just about everything. Okay? You can explain your last dream by means of string theory. Okay? That is, string theory, you know, is a result of the strings vibrating the way they do. By certain processes, whatever they are, that will be able to explain, you know, mental phenomena as well as physical phenomena. Okay. But Brian Greene notes that, you know, some physicists have this idea that you can explain everything, literally everything. They're reductionist. Everything can be reduced to strings vibrating in multidimensional space-time. And he admits that some string theorists are not like this. They're more cautious. But when Brian Greene came to Johns Hopkins last year, I went to the talk, and I did put my hand up and I said, you know, are you a reductionist or not? Do you think that everything can be explained? Come on, tell us. And he said yes. So I count him as one of those theorists that has this idea. Okay, so much for string theory. Another, and of course, string theorists use the term theory of everything, which they abbreviate as TOE, T-O-E, the theory of everything. Okay. Now, the next example I will give 4 examples here of people who either develop a theory of everything or think that it should be developed, that is, they think that it does exist. Now, if we go back into the 17th century, the mechanical philosophers said something like this. They held that everything in the universe, or at least everything that they were interested in, could be explained in terms of, well, it depends where you are in the 17th century, but if you're around Newton's time, you think that everything can be explained in terms of forces acting on bodies subject to laws of motion. Okay? And indeed, you can read Newton's Principia and look at the preface of the first edition where he says, "Our present work sets forth mathematical principles of natural philosophy. For the basic problems of philosophy," that is, he means science, "seem to be to discover the forces of nature from the phenomena of motions, and then to demonstrate the other phenomena from these forces." Okay? Well, he leaves open what he means by the other phenomena, but you know, you might think, and some people did, that everything can be explained by means of this fundamental theory of everything. Okay? The ideas of the mechanical philosophy, of course, extended well into the 19th century, and it was only, I think, and it kept changing, you know, in the introduction of a field with Maxwell and so on. But basically, this was the thought. I mean, Maxwell tried to develop a theory of electricity, but then he thought this wasn't really as fundamental as if you would explain electricity in terms of bodies in motion subject to forces. Okay, that's my second example of a theory of everything. I'm leaving a little bit vague what counts as everything, but that's important. We need to keep that a little bit open here. The third example is a recent book, came out in 2012. Probably some of you have read it. It's by Thomas Nagel, Mind and Cosmos. How many people have seen that book? Okay, I like the book, even though it's very controversial. It got a lot of very negative reviews or controversial reviews. But let me quote from Nagel. "This, then," he writes, "is what a theory of everything has to explain. Not only the emergence from a lifeless universe of reproducing organisms and their development by evolution to a greater and greater functional complexity, not only the consciousness of some of these organisms and the central role in their lives, but also the development of consciousness into an instrument of transcendence that can grasp objective reality and objective value." Well, that's very bold. I like it. So in other words, what Nagel wants is a theory, and he says it's a theory of everything, which will unite the mind and the body, okay, the mental and the physical. And it will do so, says Nagel, not by sort of combining physics with psychology in some way, but by getting beneath both, getting to a deeper theory which says that there are certain atoms, in quotes, which have mental tendencies and physical tendencies. And it's a theory that he calls panpsychic, okay? And because of the way these panpsychic atoms behave, when they get into sort of groups, they tend to develop mental properties of the sort that we know. And he wants to then have a deeper theory than quantum theory, which is a probabilistic theory, and one which will, where the probabilities of certain events will be larger than the probabilities assigned by quantum theory, because these are produced by these atoms which have mental tendencies to get into certain states, more probable states. Okay, but he says, look, I'm no scientist. I simply think because of the problems that we have with mind and body, we need such a deeper theory. Okay, so that's the third example I want to give. These last two examples are just from philosophers. The fourth one is David Chalmers. Wrote a book, Construction of the World, in which he follows out the program of the early logical positivists, specifically Carnap, to develop a theory which will or a way of expressing a theory which will enable you to derive everything you know from a set of very fundamental ideas. Okay? And what he says is, he calls this idea a scrutability thesis. And it says, and I'm quoting, that the world is in a certain sense comprehensible, at least given a certain class of basic truths about the world. In particular, it says that all truths about the world are scrutable from some basic truths. And the basic truths for him include basic physics, whatever that is, and he's very generous with his basic truths, which is one of the criticisms of the book. But he allows classical physics as well as contemporary physics. And he allows certain phenomenal truths about what you, what you perceive and sense and so on, and others. And he wants to say, look, this is called a scrutability basis, and from this basis, if you can only supply it, you should be able to deduce for him the relationship, the explanatory relationship is one of deduction. You should be able to deduce everything, literally everything about nature. That's his goal. He's not going to give you the theory. Good philosopher, he's going to say, hey, this is what you got to do, you scientists, and you got to do it in the way that I'm suggesting. Now, he says, unlike other TOE or theory of everything theorists, he says, he's generous. He's like Carnap. Carnap says, well, there are various bases from which you can deduce. I'm not going to tell you which one, and some of them, they won't all be the same. But that's the goal. The goal is to provide a set of sort of fundamental propositions about the world from which you can deduce and explain all others. Okay. So there you have four examples. They're different examples of the idea behind a theory of everything. Now, the theory of everything is supposed to be something, at least for these guys, that exists pretty much independently of us. Maybe not for Chalmers so much, but for Nagel, for 17th century philosophers, so-called, and for string theorists. And that's the way I'm going to use the term theory. It's out there to be discovered. And the question is, does it exist? Is there such a thing? And the other question, the second part of the question that I'm raising is, why care? What good is it if there is such a thing? Why should we be interested in such a thing? Okay. Now, to answer these questions, we need some, I think, more precise view of what a TOE is supposed to be. What are we committing ourselves to? What constraints should we impose on the TOE if you're one of these guys? Okay. Now, the first thing I think they want is something which is true. So if you have a theological theory, it's a TOE, says everything comes from God, that's not going to be necessarily a TOE unless it's true. So a necessary condition is truth, and I'm not going to get into an argument with you about realism or anti-realism. You can express this in an anti-realist way as well, but these guys tend to be realists. Okay. So it's not simply a theory that purports to be true, it purports to explain everything. It does correctly explain everything, and it is a correct theory. Okay. Now I will suppose, here's what I'm going to, three conditions I'm going to give you that I think they, theory of everything theorists want satisfied. That a TOE is to correctly explain by appeal to a set of laws for which no further explanation exists, so-called fundamental laws. Second, that a TOE is to postulate correctly that there are fundamental objects, strings or Nagel's panpsychic atoms, or fundamental physical and phenomenal entities in Chalmers' scrutability base, or whatever it is. These fundamental entities that are not further analyzable and that are governed by the laws in the fundamental set. And third, and this is crucial, that everything, and I put everything in quotes, whatever everything is supposed to cover, that everything that happens is correctly explained by the properties and states of these basic objects governed by these basic laws. That's the idea, that there is such a correct theory which satisfies these three conditions. Okay. Now, they put further constraints on this. They say that such a theory must be a unifying theory, okay? And of course, they don't give you a definition of what they mean, but they give you some examples. For example, they think that Newton, mechanical philosophy, Newton unified gravity. Because before Newton, it was thought that gravity is sort of the weight towards a certain body. So there was a gravity on the moon, there was a gravity on the Earth, there was a gravity on Mars, and so on. And what Newton says is, no, all of these are the same force of gravity. It's just one force. So that's an example of a kind of unification that they like. They also want a unification in the sense of unifying various phenomena, which is what Newton did. He unified celestial phenomena, the motions of the planets and their satellites, with phenomena on the Earth, falling bodies, for example. He explained those by reference to one law, one basic law, together with his other laws of motion. And they want the theory to have a certain coherence. It's sort of, you don't just, every time you have a new phenomena, you invent a new law. That's out. You want one set of laws that hang together. In Whewell's expression, they're coherent. They hang together, and they explain all these things that they're supposed to explain. Okay. So, as I say, one simple example is Newton's unification of celestial and terrestrial motion by appeal to gravity. Now, they also talk, or some of them talk, about a theory of everything as being a final theory. And it's really not clear to me, I'm supposed to take this, yeah, it's really not clear to me what the final theory, what that means, a final theory. It might just mean what I said so far, that you postulate these fundamental entities, they're not further analyzable, subject to laws which have no further explanation. That could be just a final theory. But they seem to, some of them, Stephen Weinberg, for example, who is another TOE theorist, thinks that, no, it's got to be something more than that. It's got to be that the universe has to be like this in some way. Okay? Not just that it is, but that it has to be. and the theory, the TOE, has to tell you that this is the way the world has to be. Okay, could be no other way. I'm not sure what that comes to, whether it's a metaphysical necessity, whether it's an empirical thing, that no other laws could possibly exist that are consistent with the phenomena we know, whether that's sort of an epistemic necessity. I don't think it's a logical necessity that he's talking about, but anyway, he's not very clear about it. But there is this idea. Okay. Now, so the next question you might say is, okay, is there such a thing on the horizon? Is there a theory of everything in their sense, or the sense I just gave to it? And I think the sense I just gave to it is a pretty fair one as far as what they want. Is there such a theory? Remember, I don't mean has anybody constructed such a theory. I mean, is there one out there? Just like, is there a proof of this proposition? Okay, whether or not we ever discover it. Okay, now I think the easier one to answer is, the easier question to answer is, has one been constructed? And if you take everything pretty broadly and you require truth, then I think the answer is a resounding no. No theory of everything has been constructed or discovered. One of the most fundamental problems with string theory is that nobody has ever observed a string. Okay? And there are no experiments which confirm this. And in fact, they haven't, in principle, even so far as I know, I may be corrected on this, they haven't even designed any experiments. When Stephen Weinberg came to Hopkins in the mid-'80s, he gave this lecture on string theory, which was autobiographical, and he was saying you won't have experiments for the next 50 to 100 years. That didn't seem to bother him. But at any rate, we don't have something that we know is a theory of everything. And according to Smolin, of course, he's an enemy of string theory. And never, don't believe your enemies all the time. If he's right, then it has not solved all 5 of the basic problems that he lists himself. Okay. It has not, for example, it has not given rise to the fundamental constants of nature, not explained why they are what they are. Okay. So string theory, we cannot say that string theory is a theory of everything. We're not justified in saying that if you abide by these criteria. Newton's mechanical theories have been given up, so that's not a theory of everything in the sense that I'm after here. Nagel hasn't even presented us a theory. He hasn't given us anything. He just says, I think a theory of this teleological kind should be developed, but it's up to science to do it, not up to him. So he doesn't have one. And Chalmers is not even about to give you a theory of everything. He's just to say, look, there are various ways you can talk about the scrutability relationship and various kinds of scrutability base that you can have, but it's up to science to do it. So, okay, so the 4 examples I've picked are not theories of everything. But, so we say, well, why do you guys want what you want? I mean, you don't even have one. You don't even. Okay, so they say, their response is, of course, we don't have one. It's a goal. It's an ideal. It's an idealization. This is what we should aim for. And this was very much said in the 1930s, and in fact in 1950s when Hilary Putnam and who else was in on that paper? The Unity of Science as a Working, Oppenheim. Putnam and Oppenheim wrote this paper, which was influential at the time in the 1950s, about unity of science as a working hypothesis. And they thought that this is an important presupposition of science, that to assume there is such a theory of everything from which everything can be derived. Okay? So even if we don't have one, even if we're not going to get one, it's an ideal towards which we must strive. I'm not sure why, but it is. That's their claim. Okay. All right, well, I'm interested in why. Okay. So what do we do? Why should we believe with Weinberg and Green and other TOE theorists and Nagel and Chalmers? Why should we believe that there is such a thing as a theory of everything? What reasons can we possibly give for thinking there is such a thing? Now remember, I'm not talking about string theory. I'm not talking about any particular one, just a theory of everything, a theory that satisfies these three criteria that I've mentioned. Okay, that it postulates fundamental entities, atoms, if you like, in nature, subject to fundamental laws. That is, these are things which are not decomposable into anything further, and the laws are not explained by anything further. That is, there's no further explanation of the laws, and this theory is supposed to be able to explain everything, whatever everything means. Okay, well, I suppose there is such a theory, and interestingly enough, some of these physicists give an answer to the question, whether or not it's string theory. They give an answer to the question. And I'm going to just briefly mention some of these answers. The first one I will mention is due to Steven Weinberg. And I'm going to quote from his work, Dreams of a Final Theory. Okay. And I'm going to get the right page here and give you the argument that he gives. It's a historical argument, interestingly enough. He says, if history is any guide at all, it seems to me to suggest that there is a final theory. Our deepest principles, although not yet final, have become steadily more simple and economical. It is very difficult to conceive of a regression of more and more fundamental theories becoming simpler and more unified without the arrows of explanation having to converge somewhere. And Weinberg makes it very evident that what he means is a theory of everything in my sense here, that it's a microscopic theory. Now, you know, I take Weinberg seriously. I mean, you know, he is waxing philosophical, but I think he believes what he says. And I wonder why I should believe that. How does the history of physics tell me anything about what really exists? You know, the history of physics is full of mistakes. Okay? Every time we think we have a fundamental particle, you know, like a proton, no, it's something that is made up of 3 quarks. Okay? And now the quarks are supposed to be made up of strings. Who knows what's next? Okay? So and the laws that have been discovered, which were once thought to be fundamental, or, you know, in many cases not true, like the law of gravity, or at best idealizations or simplifications or whatever. So if you look at the history of physics, you're not going to really get a good deal of evidence in favor of a fundamental theory. The most I think you can get from an historical argument about what physics does or has done is the argument, the following sort of inductive argument, that physicists have gone in a micro direction. They've also gone a macro direction too, but let's ignore that. Physicists have gone in a micro direction, so probably they'll continue to do that, okay? You can expect that. But nothing follows from that about the existence of a final theory. Okay? It may suggest the idea, you know, well, physics got to stop somewhere. I mean, there's got to be some end to this process, but that's the idea that you have, but it's certainly not supported by physics. Okay. So I'm not very happy with that argument, but I'm happy that Weinberg, you know, makes an argument for the existence of a physical theory. It's one of the few times he waxes philosophical. Okay. The next argument, I think, is more interesting, and that is from Smolin. Now remember, Smolin's a critic. So he says, well, why do these guys believe that there is a theory of everything? And I call it the unification argument. He says, and I quote from him, the mind calls out for a third theory beyond general relativity and quantum theory to unify all physics. And for a simple reason, nature is in an obvious sense unified. The universe we find ourselves in is interconnected in that everything interacts with everything else. There's no way we could have two theories of nature covering different phenomena as if one had nothing to do with the other. Okay, so that's supposed to give you some reason to believe that there's a fundamental theory which connects, relativity and quantum mechanics. Okay. And everything else. I mean, this is, Nagel gives this kind of argument. Hey, the mind interacts with the body. Okay? The old Cartesian problem. So therefore, there must be some underlying theory which connects the mind with the body. Interaction needs explanation. Okay, that's the idea. Well, there's interaction and interaction. I worry about this because, look, there's two kinds of, I don't want to call them unification, but two kinds of way of dealing with interactions. Take a simple interaction, okay? You got a parachutist floating down, okay? Now he's subject to the force of gravity, and he's subject to the force of air resistance, okay? And maybe other forces as well, okay? So I want to figure out what the resultant force is going to be. And so I combine the forces, that's all, in some way, vector combination of forces to figure out what the path is going to be. Now, for theory of everything theorists, this is not unification because I still got two forces, whether they're fundamental or not, doesn't make any difference. I still have two forces, gravity and air resistance. And I'm combining both of these. These are forces which interact. I'm combining both of these to determine the resultant force, if there is any. And that's not what these theorists want. They want something which underlies both forces. Okay? They want either something of the sort that Newton did to say these aren't different forces of gravity on each of the planets. It's the same force. Either they want that, or they want something underlying both forces, a different kind of force which explains both. Okay, they cite Maxwell's unification of electricity and magnetism. That's a bit controversial, but the idea is that the electromagnetic field explains both forces. Okay, that's what they want. But the fact that there's an interaction between the mind and the body, between the various fundamental, so-called fundamental forces of nature, the four fundamental forces of nature, suggests only that we want some way to, I mean, you have to distinguish between combining these forces in some way and finding some different, more fundamental force that explains all of them. Now, you may want a more fundamental force that explains all of them, but the mere fact of interaction doesn't by itself suggest one way or the other way. You have to look at the particular theory to see what's going on, but that's, to me, this is an interaction argument in general. It's a general interaction argument, and I see no more reason to do one thing rather than the other here, rather to go to a deeper level or just to combine what you have. So I'm not impressed with that argument. Okay, now a third argument is presented by Thomas Nagel. And this is an interesting argument. It's an argument that says, in effect, that science has to presuppose that there is a theory of everything. Let me, if I can find quickly a quote from Nagel here. It's what I call a presupposition argument. He says, science is driven by the assumption that the world is intelligible. That is, the world in which we find ourselves and about which experience gives us some information can not only be described but understood. And then he says, it seems to me that one cannot really understand the scientific worldview unless one assumes that the intelligibility of the world as described by the laws of science, the laws that science has uncovered, is itself part of the deepest explanation of why things are the way they are. So as I'm reading this, Nagel at points gets obscure, but as I'm reading this, it says that, look, if you do science, you presuppose that the world is intelligible, and you presuppose that that means that there is a TOE. There is something which explains everything. Because if there are certain, and he means completely intelligible, that if there are certain things that are not intelligible, then why would we do science? So the fact that we are doing science means that we suppose that this is the case. Now, of course, this is not an argument that the world is intelligible. Nothing follows about that, but it's an interesting presupposition argument, kind of a transcendental argument, that we have to assume that the world is intelligible to do science. Now, I wonder about that. Why do we have to assume that? You know, and indeed, do scientists really assume this? Well, I'm not convinced they do. That is, whether they assume that the world is intelligible in the sense of requiring the assumption of a theory of everything. I mean, Newton, just take Newton, okay? Newton explains why the motions of the planets are the way they are, but at the end of the Principium, a general scholium, he says, look, all the planets are on the same plane. The known planets at the time of Newton are on the same plane, revolving in the same direction. There's no mechanical explanation of this, but it's too orderly to happen by chance, and therefore that's his argument for the existence of God. So he has a deus ex machina idea here that God makes it happen that the planets are on the same plane in the same direction. Newton thought this, and he considered this a deduction from the phenomena. There was a scientific explanation of why the planets are the way they are. No TOE there, because a TOE would have explained why the planets are the way they are in terms of forces, mechanical forces subject to his laws of motion. Okay, so he may suppose that there's a scientific explanation of everything, but it doesn't mean that there's a theory of everything of the sort that, you know, these guys are looking for. Okay. Now, finally, and I'm reluctant to deal with this because it may well be that scientists who, such as Steven Weinberg and Brian Greene, who say that a TOE exists, have some kind of metaphysical idea that such a thing must exist, okay? And here I'm at a loss because they present no metaphysical argument that it must exist, okay? And I mean not an empirical one. Of course, they do have sort of as I said, the historical argument and the interaction argument. Those are supposed to be empirical. But there's a deeper idea, perhaps, that nature has to be this way. And that puzzles me. First, they have no argument for this. So maybe you don't need an argument. Maybe it's self-evident. It's self-evident that nature is like this and has to be like this. And I don't think it was self-evident to Isaac Newton like that. It has to be like this. And of course, in the early 20th century, there were vitalists in biology who said that there are certain vital forces that cannot be derived from the basic forces in physics that explain biological processes. You know, maybe they're totally wrong, but metaphysically wrong? I don't know. Anyway, that's a, you know, I think there may be some, you know, deep metaphysics going on here, and if there are going to be some metaphysical assumptions made here, A, I'd like to know what they are, and B, I'd like to know an argument for them, because they don't seem to me to be self-evident. Okay. Now, lacking a decent argument for the existence of a TOE, let's go on to the other side of the program. Well, okay, even if I can't prove there is a TOE here, I can't prove that you know, nature has this sort of thing. It would be great if we had one. Okay, it's a good thing. And so I want to know why it's a good thing. Why is it a good thing? What it would do for us if we had a TOE? Okay. So I turn back to Nagel, because he tells us. And he tells us the answer is it would be a good thing because of his idea of intelligibility. Then everything would be completely intelligible. And that's literally what he said. And the same thing with Chalmers, and the same thing with Weinberg and Green, I think. They emphasize this idea of intelligibility. That's what would make, even if one doesn't exist, it would be a good thing if one does, because then everything would be understandable. Okay. Now, this makes me wonder what on earth they mean by that. Everything would be understandable. Well, okay. So I say, you know, there's two senses here that they might have in mind. I don't know, maybe more. One sense is purely objective. It's something about the world, that the world has a certain order to it, okay? Whatever that is. And let's say that, and of course they think that what it is this, the fact that a theory of everything exists, that everything can be derived from these basic ideas and basic principles. Okay, so at least I have some idea of what sort of objective intelligibility means, that the world has nothing to do with us. The world is in a certain way. Okay. Now, they haven't proved the world is in a certain way. They just say it would be nice if it were. Okay. Now, here, I wonder why it would be so nice. Okay. And you look at even some of the opponents of string theory, or of a general idea of a TOE, and I'll mention two. One is physicists Laughlin and Pines, who say that, look, the world is just very complicated. Okay, when you get even at the fundamental level. They offer an example of a quantum mechanical equation relating charge and mass of electrons and atomic nuclei that covers macro and micro bodies. And they write, however, it is obvious that the theory of everything is not even remotely a theory of everything. We know this equation is correct, however, it cannot be solved accurately when the number of particles exceeds about 10. No computer existing or that will ever exist can break the barrier because it is a catastrophe of dimensions. Okay, this was an article in the National Academy of Sciences. I'll pick someone more familiar to you, Nancy Cartwright. Nancy Cartwright gives an example which she got from Otto Neurath in the 1930s, in which a $1,000 bill is swept up by the winds. Okay? Now you may know, or think you know, all the forces acting on that $1,000 bill. Okay? But there is no way you're going to compute from anything where it's going to land. Right? It's just too complex a thing. And so you might say, what good would it be? You say, well, I know all the forces acting and I know all the laws, but I can't tell you why it landed exactly where it did, because you can't compute it from your basic assumptions. Okay, that's her example. And I think what this suggests to me is that we don't want that idea of intelligibility. We don't want the objective notion of the world has a certain order to it. We want a much more personal one. We want intelligibility to us. All right? That's what science wants. Remember the story of Job, okay? And Job said to God, how can you punish me like this? I don't understand it. And God says to Job, of course you don't. You'll never understand it, but it's rational, it's reasonable, you know, you can't understand my ways. Okay, that's not what we want. I mean, that's not going to make, maybe it made Job feel better, maybe it makes you feel better, but that's not, you know. What you want, if you're a scientist, is to understand something in the way that scientists understand things. Okay? It's a contextual idea, not an objective thing about the universe. Or at least if it is an objective thing about the universe, then you want to be able to understand what that comes to. Okay, so what I'm suggesting is that intelligibility of the world in the objective, unrelativized sense would be a good thing as far as science is concerned, only if it's also intelligibility in the contextual sense, in the sense that we can come to understand it. Okay. But if you're going to contextualize this, if you're going to relativize this to our needs or scientists' needs, then you might as well go all the way. You might as well say, look, what we're interested in is understanding something at a given level, the level we're pursuing it at, relative to the problems we're trying to solve, okay? And this is what I'm going to call Newtonian intelligibility. Not because it refers to, you know, bodies in motion subject to forces, but because it refers to the idea of I want to understand things at in a certain way, and see if I can. I want to understand things by developing a law, in this case a law of gravity, which explains why the planets and their satellites move the way they do. And that's what I'm really after in the Principia. That's the, you know, the final sort of thing. And Newton then goes on to prove his law of gravity, which then will explain the elliptical motions of the planets and their moons. But at the very end of the Principia, very controversial part of the Principia, he says something very powerful and interesting. He says, look, I can't explain why the law of gravity operates the way it does. In other words, what's causing gravity to be a force which acts over a distance. Newton didn't think it did, but he says, what I know is that the law of gravity is true and that it explains these things. And then he says in Latin, satis est, it is enough. And I take that seriously too, because that was his program. He wants to understand why and how the planets move, what the forces are that are operating here, and how they operate in accordance with what laws, and he does so, you know, deriving this from the phenomena that he began with, and that is enough. That's his problem in the Principia. He did spend part of his life trying to figure out why the law of gravity does work, but that's not his program in the great work, okay? And that's what I mean by contextual understanding. And I think that pervades science. We want to understand something at a given level, at a given time. We may want to take it further at another time, but that's complete understanding relative to where we are at the moment. If that's the case, and I'll give you a quote from my other favorite scientist, Maxwell. Maxwell writes, "In all scientific procedure, we begin by marking out a certain region or subject as our field of investigation. To this we must confine our attention, leaving the rest of the universe out of account till we have completed the investigation in which we are engaged." Okay, so Maxwell is not searching for a theory that explains everything, right? When he does his theory of electricity, when he does his kinetic theory of motion and molecular motion, he's trying to explain a certain range of phenomena in terms of certain laws or in terms of certain assumptions he's making. And that's enough for that investigation. In fact, in kinetic theory, he arrived at certain conclusions which didn't seem to correspond to the facts. And he said, sure, that's another investigation. My theory is not perfect. My theory has some counterexamples to it. But, right now, I've satisfied the conditions that I said I would. I've developed a kinetic theory on the basis of certain assumptions about molecules. And I've made these things intelligible to you at the level that I'm trying to do it. And please don't tell me that I've failed or that I have not provided you a basic theory from which everything else can be computed. And that's the kind of understanding, I think, that science is in search of, which means, why would we want a theory of everything? If, as a matter of fact, the theory of everything is such that, as Laughlin and Pine say, you could never use to compute certain events, as Nancy Cartwright said, who cares, if your theory can't tell you where the $1,000 bill is going to land, you're not interested in those problems. That's not what you're trying to solve. You're trying to solve certain other problems at a certain level. Whereas theorists of everything want to solve every problem at the deepest level, okay? And so I don't find a sufficient philosophical motivation for this, though I know other people do. But I take Newton's line here and Maxwell's line. It's sufficient that I've solved the problems that I want to solve, if I have, at the level I've done, and I realize there's further problems. As Maxwell said, let's just isolate this for a while before we get on to the next. So I work contextually in that way, and furthermore, I don't presuppose at all that everything is intelligible in the Nagelian sense, that is, that there is a theory of everything which can explain everything. Don't make that assumption at all. So it's not that I'm saying to string theorists, don't work on string theory. It's not that I'm saying to Nagel, don't develop your theory, your teleological panpsychic theory. No, go ahead, Tom. Tell me what it is first, and then we'll see what happens. Or the string theorists tell me how you solve this problem, how you solve that problem. But don't base this search on the idea that unless you have a theory of everything, you haven't explained anything. Okay, thank you.
Thank you, Peter. This was very stimulating. Now, this kind of questions.
I'm just curious to know how randomness interacts with the
I have not thought about that. And the question is, what do you mean by randomness? Okay. If you mean that not even statistical laws would be operative here, I mean real randomness, so that there's no pattern whatever, then of course, as a scientist, you're in trouble, right? Because what are you asking? Okay.
Well, I think both kinds of randomness, we interact with the prospects.
I'm sorry, can you?
I think both kinds of randomness matter. Even if you ask the laws, still have things that are not explained if things happen according to these laws.
Well, look, in the 19th century in statistical mechanics, you have randomness, but underneath it, the assumption was at the at the underlying level, there is no randomness. It's just that you have to treat because you're dealing with large populations of, let's say, molecules, and you have to deal with these statistically, just as the life insurance companies have to. Your death is caused by whatever it is. There's no accident, but we treat you as just one member of a population, and we figure out, the probability that you're going to die, of your death, and so on, based on your age and other factors and so forth. And that's how we have to go. So that's one kind of randomness, where we simply assume that there are underlying determinism. Now, when you get to quantum mechanics, you can't make that assumption anymore. So philosophers worry about how, quantum mechanical explanations explain things. Okay, you might have noticed I said nothing about explanation here. There are different views, very strong theorists of everything don't say much about explanation. It's interesting. Nagel seems to adopt the idea that that goes back to the idea of Hempel in the statistical model of explanation, that if you're going to give a probabilistic explanation of something, saying that this happened because of that event, and the probability of this happening because of that is whatever it is, then the probability has to be high. That's one theory, that statistical explanation of some event requires high probability. Okay. Another theory, which was due to another philosopher of science, Peter Railton, is that, and also Wesley Salmon, is that you don't need high probability at all. You just need probability. So I can explain why a very low probability event occurred by giving you just the probability. So I can explain, for example, suppose I go to Las Vegas, okay, and I'm playing if there was such a thing, I'm playing the game of coin tossing, okay, and the coin comes up 100 heads in a row, okay, and I'm really angry. I said, you're cheating. I go up to the head guy there at the casino, and I said, there's cheating going on here. And how do you explain the fact that 100 heads in a row? I lost a fortune. And he says to me, well, I explain to you, it's very easy. Let me just introduce you to some probability. It's a fair coin. Probability of getting heads is 1/2. Therefore, the probability of getting 100 heads is 1/2 to the 100th power, not 0. Okay, that's your explanation. Well, you're not going to be happy with that, but Peter Railton might be happy if that's a fundamental. Yeah, I don't think he would be happy either. He thinks there are fundamental laws of quantum mechanics like this, but that's a caricature of his position. So it really does depend on what theory of explanation you have as to what kind of a theory of everything you're looking for. Okay, but again, since many of these guys are scientists, they don't have a theory of explanation to go along with it.
I have a million questions on.
Oh no, yeah, yeah.
Okay, so let's assume some random person came along and actually did have a theory of everything. How do you think the scientific community would approach that? Do you think they'd be open to accepting that? Or do you think there's...
Well, what's your question? You mean you're accepting the theory or accepting the idea of the theory of everything?
Well, accepting a theory, any idea of theory.
Any idea of theory of everything. I don't know. I think the first response might be produce it, okay, and show me that it's true, and show me what you can explain, which is what I would say to someone who thinks there is a theory of everything, without telling me what it is. I say, okay, tell me what you think it might be. Okay, in other words, spell it out a bit. That's what I want to tell Nagel. Tell me what the laws are here, a little bit. You don't have to work it all out. And tell me why you think it might be true. Don't give me a priori reasons for thinking your theory has to, or some theory like that has to be true. Give me some empirical reasons for thinking there are panpsychic atoms, which when they get together in communities sort of start looking a bit like humans. I want to know. I want to know why I should believe. I want to know why I should believe that. What evidence you have for that? I suppose that would be my first response to this. But my deeper response would be, who cares? I mean, unless you show me why such a theory is important, what it's going to explain, and how it's going to explain it. I go along and doing my science the way I was doing it before. Like Newton. I say, okay, you want to explain? I'm going to explain now why the planets move the way they do. Well, I do some forces. And I'm going to show you there's just one universal force acting here. I'm going to show it how it acts, and I'm going to explain how the tides work and so forth. But I'm not going to explain why you had that last thought of yours. Okay, it's very limited in that sense.
So in terms of this is actually more so related to the first question in terms of the true randomness, in the sense that for specific constants such as like the vacuum permeability constant or various other scientific constants that are just that seem completely arbitrary like the speed of light, how can we dispute a theory of everything or a theory that defines those constants without disputing the fact that those constants themselves are completely random or arbitrary?
I'm not sure I understand the question. As I understand it, what string theorists want is this theory from which you can derive the value of the constants, that the constants must be this way, okay? The speed of light must be this way, whatever. And they think of this then as not a random thing. It's not happened by chance. But even Smolin or, let's see, I think Brian Greene, even more impressively, who is a theorist of everything, says, well, maybe the constants of nature are just mere accidents. Okay? Maybe they are just random things. There's nothing further to explain. Maybe that's the way the world is. Okay? And he says, look, it's not that I can give you an argument that there must be an explanation here, but I'm going to hope there is. Yeah. So yeah, I mean, would you feel better about the universe if you were told there is a reason reason for everything? You're Leibniz, okay? You're told that if anything is the case, there must be a reason for it, okay? And so if the gravitational constant is a constant, there must be a reason for it being the way it is. If light, speed of light is a constant, there must be a reason for that. Why? Why?
Actually, in Bradbury's Elevated Universe, he actually explains that, supposing that, for instance, there are just various other universes, the reason why the constants are the way they are in our universe is because they have to for the laws that we have and observe to come to be. Like, for instance, if the electron had a slightly different mass, then our universe can't exist as it is today.
Yeah, okay.
So, for instance, it just is.
Sure. Well, with black, so the universe wouldn't exist. So what?
That then we would be.
Is that an explanation? Yeah.
I'm so sorry for that.
Okay. So then, yeah. Maybe it's an accident that the universe really exists. Is that? I mean, this just takes it a step back.
Let me interrupt this in a live stream. So there's a question from some virtual listener. So make it for this.
Okay, so
all right, I got you.
So I wonder whether a philosophy of nature can be understood to be a theory of everything, and if so, would that satisfy the criteria? Generally, philosophies of nature seek to explain phenomena according to fundamental laws or concepts, and these explanations are more philosophical than scientific in nature, though they do tend to stem from scientific investigation. Thanks.
Oh, okay. What are you reading from? From philosophy of nature or what? Or just something you had? Okay, okay. So what is a philosophy of nature?
So this question came from someone who is actually watching this live. So someone asked this question.
Yeah.
Someone
asked the question.
Yeah, they typed this question.
Okay. Oh, I didn't realize.
It's a question to you.
Oh, question to me. Okay, from someone unknown. Okay. Gotcha. I don't know. Look, there are philosophers who think that the job of philosophy is to explain the way the world has to be. Okay? And that's why I'm a little bit reluctant. That's sort of a metaphysical idea. The world has to be this way because of whatever. Okay? And I'm reluctant to deal with that because it reminds me of Descartes. Okay? The world, Descartes wanted to explain, in his physics, wanted to explain the world, the way the world had to be, the laws of motion, as a result of God creating the universe, and creating the universe in such a way that motion had to be conserved. Now, he was, as far as I know, the first to come up with the law of conservation of momentum, although his notion of momentum is different from the modern one. But God has to work this way because otherwise God would be imperfect. He would either change the total amount of motion in the universe from what it was before, which means that either before it was imperfect and now it's perfect, or it was perfect before and now it's imperfect. So the world has to be this way because of God. Well, how does he know that? That would be my empirical response to that, of course. It was Newton's empirical response to Descartes when he felt a nice mood towards Descartes. But the only way, said Newton, that you know the way the world is by looking. There's no way the world has to be. Okay. I'm simplifying Newton now, but I like that simplification. Yeah. And so, if a philosophy of nature is supposed to be a theory of everything from which you derive all these things, then kindly spell out what the philosophy of nature is, and show me how it does explain these other things. And I'll bet you can't do it. Okay, that's my maybe simple-minded response to philosophers.
Can I try a question? I was surprised that there was no reference or mention of explanation. You said
Yeah.
It seems to me a kind of an obvious motivation for a theory of everything would be something like that. Understanding is a medical explanation. Explanation is got to do with minimization of the things we take as explainers. Unification in this sense, therefore, we're better off to try to unify everything in theory, because this will provide the best or the most explanation and understanding of what's going on. Now, it seems to me these lines should be dissociated from the claim that this theory of everything there is the final theory. There can be a theory of everything, it's not final. That is, it's our best attempt now to unify everything, and we hope we've done our best. But because it's an empirical theory, there are evidence coming up. In the future, we might tell us we will be able to advise it. But I think it's unfortunate that the two thoughts are together, the theory of everything and the final theory. And the unification motivation might be enough motivating why we look for it, even though it might be very difficult to possible.
Well, there's a lot of things in what you say, but let me go back to the idea of explanation has to be in reference to laws, to unify things and so on. If you take a contemporary well, reasonably contemporary view of explanation, objective Hempel's view about explanation in terms of you explain a phenomenon by bringing it under a set of laws, and in his deductive model, he has a requirement that you deduce the thing you're trying to explain from the laws in the explanation. But nowhere does Hempel say that in order to explain something, you have to explain everything. And he doesn't even say that you have to explain what you're trying to explain in the most fundamental terms. You can give macro laws to explain certain macro phenomena, if you can do that, if the laws are true and so on. So what you're saying is that we physicists, we scientists, desire to explain everything at the most fundamental level, to unify everything in the universe, right? That's the line you're considering here. And I'm saying sometimes we do, sometimes we don't. Sometimes we're satisfied, as Newton was, to explain gravity, to explain the motions of the planets by just a single law, or the 3 laws of motion were used too. And we haven't explained everything that way. Sometimes if we're Maxwell, we use something to explain certain gas laws, and we haven't explained electrical properties of gases. So what? Is there some fault with that? Is there something? Of course, trivially, we've left out some things. But is that should we say, therefore, the behavior of gases is not understandable? Should we say that the behavior of electricity is not understandable? Should we say that the motions of the planets is not understandable? That's what I'm objecting to. In other words, if you're going to take the line that to explain something, you must be able to explain everything. You must be able to explain it at the deepest level and a final level. That is way away from what I think scientists do. So I asked string theorists, I mean, what do you want? And the answer is they want to unify these 4 basic forces of nature that they postulate. When they wax philosophical, they start to talk about reductionism and explaining everything else in terms of the 4 basic forces of nature. And that's where I say, that's not something that I think is possible or reasonable or what we care about. Okay. Well, yes.
Thank you very much. This was a very enjoyable talk. So I want to go back to something that you said when you were speaking about whether or not a theory of everything has yet been constructed.
Yeah.
And when you were considering string theory, at least part of your response to that is that no one has any idea how to test whether string theory.
That's what they said, yeah.
So I'm curious, do you think it's possible to have a theory of everything that provides some sort of unification, say conceptually or mathematically, but doesn't make any different predictions from our current best physical theories?
That doesn't make any different predictions.
Yeah.
Sure.
So might not string theory be a theory of everything that provides some useful unification, yet it doesn't make any
It might be.
predictions?
It might be. But we have no reason to think it is because we don't know whether it's true or false. One of the conditions on a theory of everything is not that it be any old theory which offers an explanation, but it be a correct theory, which offers correct explanation. I think that's what these guys want. Okay, not just some theological theory or some metaphysical theory which makes up various explanations of why things are the way they are, but a true theory. Okay, so we have no idea, if you believe some of these string theorists, whether strings really exist, because we have no experimental reason to think so. So that's what they want. So yes, of course, there might be a correct theory of everything out there, and string theory might be that theory, but we have no reason to think so. Okay, and furthermore, don't give me arguments of the form. That's what I'm saying. Don't give me arguments. But unless we have a theory of everything, the world is not completely understandable. That's true in this purely objective sense, but I think we're not interested in that purely objective sense. We want the sense of interest to Job, I want to understand why I'm being punished this way, okay? Don't give me this idea, it's beyond you. You can't determine, you can't understand God's ways. I don't want to hear that.
Wait. We need the mic back here. Can I just speak up?
I can't hear you, but
Okay.
if you could, or just come up front within spitting distance.
Thank you, Peter. This was good. I really enjoyed it. I think you're absolutely right. There's no reason whatsoever to think there must be a theory of everything in the sense that you're talking about. But I think there is a motivation underlying some of what string theorists do, and also underlying the argument from Lee Smolin that you quoted for why we should think there's a theory that unites.
The unification argument.
General relativity and quantum mechanics. That's quite independent of these dreams of a final theory, which is that, okay, you've got general relativity, it's a good theory, we like it, it's a good theory of gravity. We've got quantum mechanics, it's a very good theory of matter. General relativity has this, Einstein's field equations, which has on one side the Einstein field tensor, and the other side a matter stress energy tensor. But hey, wait, that stress energy tensor, that matter tensor is supposed to be matter as it really is, which is quantum mechanical. And if I can't put something quantum mechanical on one side of the field equation in general relativity, I can't really apply general relativity to the sorts of matter I think is in the world. And I think so. That's the motivation behind wanting a theory that unites GR and QM, and that's a very, very different sort of motivation from this. There's got to be a theory of everything.
Yeah, right. And you're talking now about motivation, and I wasn't talking about motivation. I was saying, why suppose there is a theory of everything? That was my question, which is what these guys suppose. Okay. Now, it may well be that in the case of general relativity and quantum mechanics, it would be terrific for there to be a unified theory here. Because you're dealing with very different kinds of, well, you're dealing with phenomena that, are both quantum mechanical and relativistic. Just as, Maxwell said it'd be very interesting if we could get a theory that would cover both electricity and magnetism. I want to be able to do that. But the fact that you want to be able to do that something cries out to be done, is no evidence that it can be, that it is. Okay? And the only way that it can be done is to do it. In other words, what I'm suggesting is, and Lee Smolin agrees with this, that this is, he gives you this unification argument as what's lying behind the idea of string theory. But then in the end, he says, of course, this is not a logical argument that such a theory exists. It gives you, it explains maybe the motivation for searching for such a theory, but it is no reason to think that one does exist. Okay? That's his line, and I think that's right. But of course, he's a critic of string theory.
Well, it's not a reason to think a theory of everything exists in the sense you've been talking about.
No,
it is a reason to think that a theory in which we can actually do gravitation for the world we live in exists. Yeah.
Look. Let's go back to a simpler example. A very simple one. I think it was 1908 that Rutherford did his experiments on gold atoms, in which he said, in which he sent alpha particles through gold atoms and noticed that some of them bounced back. And how to explain this? Well, explain this by saying that the nucleus, that most of the alpha particles go right through the gold without any disturbance, but some of them get near a nucleus. And so the atom must consist of a small nucleus in the middle somewhere, surrounded by electrons orbiting. And then he said, but look, if electrons orbit in some way, then they must lose energy according to classical electrodynamics. And therefore you have unstable atoms. But gold is not unstable. Atoms are generally stable. So we got a problem. I don't know how to solve it. There must be a solution. Okay, I agree, there must be a solution. That's, you know, that's what I'm trying to get here. And it was only in 1913 that Niels Bohr presented a solution on the basis of very little evidence that, you know, there are stable orbits. But the mere fact that you've got a contradiction, if you like, is no evidence that there is a solution to the problem. It's a great motivation for trying to get one. But I'm looking for evidence that there is a solution here. Okay? There is some underlying theory which gives you the right answer. And the fact that Rutherford produced these experiments is no evidence that there is.
It's time for one last maybe quick question. Okay.
So you said a moment ago that, before Wayne's question, that you granted to Nagel that if there is no theory of everything, then the world is not intelligible in the objective sense that you... No,
I didn't grant that. I said, let's grant that to Nagel.
Okay, well, you were...
Let's give it to him, that there is this sense of intelligibility. I don't particularly agree with that, but let's suppose that intelligible for him means, you know, this theory of everything exists. Okay.
Yeah, so I want to point out in any case that there is a way that the world might turn out to be not, that there might not be a theory of everything, but it's still intelligible in that objective sense. And so that's a different response you could pursue with Nagel. It could mean to say the world is not, there isn't a finite set of axioms such that you can plug in initial values and deduce everything.
Right.
But it could be that sort of, it's a bit like arithmetic. You can't deduce all the theorems of arithmetic from any finite set of axioms. And so you have to kind of, picking certain axioms, you can deduce certain facts.
Oh, you're talking about Gödel's incompleteness?
Well, not specifically. It's like, you know, because we're talking about contingent facts about the world, so it's a different subject matter. But it could be analogous to that.
Okay.
It could be that the contingent facts are, and in a way that's analogous to that, can only be deduced sort of piecemeal given the right axioms. And so there's kind of no way of wrapping your mind around the whole world, but sort of piecemeal you can do it.
So there are truths which are truths in the real world which are unproven.
Sorry.
The analogy would be there are truths about in the world, real facts about the world that we could never derive from our theories, no matter what.
Yeah, and you have to pick the right theory.
Yeah, but then Nagel will say that that's unintelligible. That's not complete intelligibility. Okay?
It's kind of intelligible at the limit.
I'm sorry, what?
It's sort of intelligible at the limit. I think that's not working. It's intelligible at the limit. Or it could be...
well, I'm not sure what that means at the limit.
Well, if you just add more axioms, you will get to any fact that you want to explain. If you know, or think about another example is, there could be turtles all the way down. It could be that sort of, there is no lower level of reality.
Yeah.
And so there are sort of theories that explain every level.
Yeah.
And you can keep going down.
Yeah, yeah.
And then, you know, on that world, in that world is intelligible, but there's no theory of everything.
No, in fact, you know, Karl Popper said there's no end to explanation. Okay? And anything can be explained further and further. In other words, there's no final explanation for anything. And Stephen Weinberg refers to that passage in Popper. He says it's nonsense. There's got to be a final theory. Okay? So I found that very curious. Why? Why does it have to be a theory of everything? Your point is that everything can be explained piecemeal, all the way down. But their point is, no, unless there's some, their claim is, unless there is some final thing which doesn't have an explanation, which is sort of self-explanatory, or must be the thing, you haven't really explained anything. Okay?
Yeah, so I think
That's the line, and that's what I'm objecting to.
Yeah.
With this pragmatic idea of explanation.
Yeah, so my point is these are kind of ways the world could be that would make Nagel wrong, but that doesn't require us subscribing to changing the definition of intelligibility.
Yeah, well, I agree with that. Yeah, absolutely. Change the definition of intelligibility.